Okay, let's switch gears in this example, and instead of finding an indefinite integral, let's evaluate this definite integral. So we're going to come up with a numerical value as our answer to this question, right? But of course, to evaluate the definite integral, we know by the fundamental theorem of calculus version 1, right, that we need to find the antiderivative of this integrand, which is e to the x over 1 plus e to the x. So I'm going to find this antiderivative by substitution, of course. And in this case, I'm going to let my substitution variable u be equal to 1 plus e to the x. In other words, the denominator of this fraction. Because I'm hoping for that maybe a natural log will be involved in this antiderivative. All right, let's see what du dx is now. So we can solve for dx, and of course the derivative of 1 plus e to the x is very straightforward. The derivative of 1 is 0, and of course derivative of e to the x is just itself, so that's very clean. And now when we solve this for dx, well, I'll multiply both sides by dx, and then after that divide both sides by e to the x power, and so I'm cutting a couple of steps out here, but I think dx will end up being du divided by e to the x after we go through that algebra, right? But if you don't see that so clearly, you should carry out the algebra yourself, right? Multiply both sides by dx, multiply left and right by dx, and then divide both left and right by e to the x. So you'll have dx isolated on the right-hand side of this equation. All right, so we're going to make this substitution. We're going to substitute du over e to the x for dx, and then of course for 1 plus e to the x, we're going to substitute u, right? So we have maybe an expression that we can integrate more easily. So I'll have e to the x over u times, and then du over e to the x, right? And of course, we know if the substitution is the correct one, right, or if it's going to work properly, the x's should be eliminated from our integrand, and that's exactly what's going to happen here, right? The e to the x's will divide out, and so we'll end up here with just this new definite integral. And that, of course, is a reciprocal function, and that one we can integrate by using natural log, right? So we have here, whoops, we have the antiderivative of d to the u over u is just going to be natural log of the absolute value of u, and then of course we want to evaluate this between those limits of integration, right? Which are 1 and 2. Now, before I actually insert the limits of integration, this is really important. You need to undo the substitution, right? You cannot directly substitute in your limits of integration until you have converted this antiderivative back in terms of x, because these limits of integration are limits along the x-axis. So we have natural log of the absolute value of 1 plus e to the x, and then we're going to evaluate that from 1 to 2. Now, in this case, 1 plus e to the x is going to always be positive, and it's especially going to always be positive because the limits of integration are also positive numbers. So between 1 and 2, e to the x is definitely positive. It's always positive anyway, okay, whether your limits of integration are from 1 to 2 or not. So to make a long story short there, we don't need the absolute value bars. This quantity that's inside the natural log is going to be positive. So I'm going to take those off. And now we can actually, I think, carry out the arithmetic, right? So I'm going to substitute 2 for x. So I have the natural log of 1 plus e squared, right? And then I'm going to substitute 1. So I have minus the natural log of 1 plus e to the first power, which is just e. Okay. So notice now this is a numerical value, right? Because you no longer have any variables. We don't really have a clear idea of what number this is, but it does involve any variables. So we could estimate this expression with a calculator, right, already at this point. We can simplify this slightly, but not a lot, because here you have difference of natural logs, and so remember you can combine that as a natural log of a quotient. So this is the natural log of 1 plus e squared divided by 1 plus e. That doesn't really help us a whole lot because we cannot reduce this fraction immediately, but nevertheless it does make the expression look a little bit simpler. And now with a calculator, you can estimate 1 plus e squared. You can divide that by 1 plus e, and then compute the natural log of all of that, and that will give you a decimal approximation for this definite integral. But this is the exact value of the definite integral, right? Okay. So I'm not going to do the decimal approximation. You can do that with your calculator or with Desmos perhaps. This is the exact area under this curve from 1 to 2 along the x-axis.